Hello and welcome to this video about work done. In the equation sheet that you'll get in the exam, you'll get work done described in this equation. Work done equals force times distance, and in that equation you'll get what each of the letters mean. You'll get the W equals work done, F equals force and D equals distance, but you will need to remember these units. So you've got a J for joules, capital N for newtons and M for metres. Now you might be thinking, well, I recognise that unit joules, okay, I've seen that before in terms of energy. Energy is also measured in joules, because actually, importantly for this topic, you need to remember a really important fact that will come up again and again in these questions, and that's the idea that work done is actually the energy transferred. That's why both of them are measured in joules. And that's really, really important to remember, that work done is energy transferred. I'd write that down on a big post-it note and put it on your wall and try and remember it. That's why they're both measured in joules. And essentially, all work done is describes the fact that when a force moves an object, work is done, or energy is transferred. Okay, so when a force moves an object, work is done, or energy is transferred. So we can think about this as how much energy is transferred when a force is applied to an object over a distance, or in other words, we say how much work is done by that force over that distance. And these are some typical questions that you might be asked in the exam. So we'll start with some simple ones. First of all, you might have something like this: calculate the work done when a box is pulled with a force of 10 newtons for 0.5 metres. So you need to underline the key parts of the question and then write down what you've got. So you've got the F there for force and the D for distance, and then we just need to put our numbers in. So W equals F times D. So W equals 10 times 0.5, which will give you the work done as 5 joules. Don't forget your units. So normally a couple of marks for these kind of questions, putting it into a relatively simple equation. Again, another example that you might get is something like this: when someone is pushing an object with a force over a particular distance, and this says calculate the work done when a trolley is pushed with 20 newtons of force over 15 metres. Now, what they might do in the exam is give you some random other bit of information that you don't need, and you need to work out that is in kilograms, so that is a mass, and I don't need mass for my equation here to calculate work done. I need a force, which I get from over here, a distance, which I get from the 15 metres here, and I need to put it into my equation. So work done equals force times distance, so work done equals 20 newtons times by 15, which will give me 300 joules. And that is the work done when this object is moved with a force of 20 newtons over 15 metres. Okay, so if you're happy with those kind of questions that we've just gone through, that's a really good start. And the next really important step is to remember what we talked about earlier, and the idea that work done equals energy transferred. And I want to highlight a particular thing that will be really helpful for your exam. So when we did these questions last time, we calculated the work done by timesing the force by the distance in each equation. So we said work done equals the force times the distance. And in our calculations, we calculated 5 joules of work done in that question, and down here we calculated 300 joules of work done. What I want to highlight to you is something that comes up really commonly in the exam, and that is when they ask you after you've calculated this work done question, they often say for 1 mark, and that would be your key indicator, they say calculate the energy transferred. It's only 1 mark, and that's because you're simply going to just copy down that same number that you had before. And in some cases they have this, and in so many cases they have this after the question, and people get really confused. But if you remember the rule that we talked about earlier, which was work done equals the energy transferred, because then both measured in joules, remember, then you can simply take this number that you calculated for work done and then put it underneath. So we get 5 joules here, and down the bottom, just taking that number, putting it down, and we'll have 300 joules there. So look out for that in the exam. That 1 extra mark after you've done a load of calculations stumps people a lot of the time, but it's an easy mark to get. Now we've looked at work done in using the equation. Now here I'm just going to introduce a couple of more of the difficult parts of work done, which link work done by and against friction to an energy transformation. So first of all, if we talk about this meteor going through the atmosphere, as it's going through the atmosphere, it will have air particles colliding against it, providing a resistive force. Okay, so it would be like an air resistance, for example, special type of friction, which will be providing a force in this direction against the motion of the meteorite. Now the meteorite itself, as it's moving, it's going to be transferring kinetic energy, and because it's moving against this frictional force, the object will heat up because the kinetic energy is transformed into heat energy. That is why you get these meteors burning up in the environment. So at the moment we've got it moving with kinetic energy, and that is transformed into heat energy when work is done against friction. So this here is what we need to remember. When work is done against frictional forces, objects heat up because the kinetic energy is transformed into heat energy. Just in the same way that if you were to push someone over a carpet, there'd be obviously frictional forces from the carpet acting against your motion, but as you do that, your kinetic energy is transferred into heat energy and you'll end up with a carpet burn. Okay, so think about that idea that when you're doing work against friction, you're going to heat the object up. Now also we need to think about, it's quite similar in the way that the work is done by friction. So work done by friction forces. So this is kind of linked more to braking systems, whether you're going to be braking on your bike or in your car, for example. And you're going to want to reduce the speed of that object that you're moving. So at the moment, all the time they're moving, they will obviously be transferring kinetic energy. And when the brakes are applied, kinetic energy is reduced and the temperature of the brakes increases, because in the same way you've got kinetic energy being transferred into heat energy. So when the brake pads are against the wheel, because of that work done by the friction, the kinetic energy which is being transferred by the car is transferred into heat energy. So your brakes will heat up as well. There's quite a lot to remember. Perhaps pause it and have a read through just to check your understanding. But the main idea that I want you to get is when work is done against friction or by friction, the energy transfer that you get is from kinetic energy into heat energy. And if you remember that bit, that's all that you'll really need for your exam. Finally then, one step up, we're going to relate work done to another equation that we've looked at before. We're going to relate work done to this equation here, okay, which is the gravitational potential energy equals mass times gravity times height. And it's all to do with this phrase that we need to get our heads around, which is when an object is raised vertically. So when you lift an object up, work is done against gravity and the object gains gravitational potential energy. So if you remember before, it's just if we say work done is energy transferred, it's just like thinking about it as an energy transfer. So as you're lifting the object, you're transferring kinetic energy into gravitational potential energy. And because you've got an energy transfer going on, you're talking about doing work. So that the object, if you were then, for example, to place it on a shelf, it would have gained and be storing gravitational potential energy. So what they'll do in the exam to try and trick you out is they'll ask you about work done, but they'll give you the information for this equation here, mass, gravitational field strength and height. But what you need to remember essentially is because work done is energy transferred, you can think about it that work done is mass times gravity times height when an object is raised vertically. So let's have a look at this example here. It says you lift a bottle of milk from a shopping bag on the floor to a refrigerator shelf that is 1.2 metres high. If the bottle has a mass of 2.4 kilograms, how much work did you do against gravity? Okay, so it wants you to calculate work done, but it's given you a height and a mass. And the first thing that you'll probably do is go to your data sheet and have a look and get really scared because you can't see an equation that links W, M and H. And this is where it comes in that you need to remember this bit. It's so important. And work done is energy transferred. So you think to yourself, can I work out some form of energy? And then if I can, I just need to remember that, well, that is work done as well. So if you get these values here, and also in the question you'll get the value for gravitational field strength, because they'll give that to you, but you may well remember that on Earth it's 10 newtons anyway, 10 newtons per kilogram, sorry. Okay, so with all this bit of information, the one thing that we can calculate is gravitational potential energy. So gravitational potential energy equals 2.4, which is the mass, times the gravitational field strength, which is 10, times by the height, which is 1.2. So if you put that into your calculator, you will end up with potential energy, gravitational potential energy is 28.8 joules. And at that point, if you remember that energy transferred equals work done, then you also know that this is the value for work done. So work done equals 28.8 joules. So just to stress the importance of remembering this point up here, which is that work done equals energy transferred. Okay, it's super important that you remember that, because then you'll recognise when they ask you a question about work done and you're only given the stuff that you can work out for energy, you'll remember that the value that you get is also the work done. Okay, so here's some questions for you to try. If I write up here the equation for work done equals force times distance, and in case you need it, gravitational potential energy equals mass times gravity times height, where gravity is 10 newtons per kilogram. So if you pause the video and have a go at these questions yourself, then you can come back and see if you got the answers correct. So question 1 says calculate work done by friction when a bag was pulled at a constant speed with a force of 20 newtons across a carpet for 15 metres. So here we've got our D and here we've got our F. So we just put these numbers into calculator. Work done equals 20 times 15. So work done equals 300 joules. Now don't forget, always show your work in the exams, because if you make a silly mistake, then you might still get some of the marks. So this question says calculate the work done when a spring is pulled down with a force of 10 newtons and extends by 15 centimetres. So here we've got our force and here we've got our distance. Now if you'd put into your calculator 10 times 15 and came up with 150 joules, you would have got some marks for this equation, but you need to have noticed, and they'll do this all the time, especially in higher. Sometimes in foundation you might just have one question where the units are different, so you don't have to worry about it too much. But you need to recognise this. They've given you the distance in 15 centimetres. So first of all we have to convert that to metres. So 15 centimetres divided by 100, because there are 100 centimetres in a metre, will give us 0.15 metres. We can then put that into our equation. Work done equals 10 times 0.15, and we get the work done is 1.5 joules. Final question then. You lift a cat from the ground and hold it in your arms so that it is 0.8 metres above the ground. If the cat has a mass of 9 kilograms, how much work did you do against gravity? So they're asking you to calculate work, but they've given you a height and a mass. This might be where you go to your equation sheet and can't find that equation linking work done and mass and height. So they'll also give you in the question the gravitational field strength, which is 10 newtons per kilogram. Okay, so if you struggle to work this out, that's probably why, because you need that extra bit of information that we talked about before. But here we have then gravitational potential energy equals 9 times 0.8 times by 10. So the gravitational potential energy equals 72 joules, and we just need to remember that work done equals energy transferred, so work done equals 72 joules. Okay, apologies if you struggle to work it out because you didn't remember this value here. Don't worry, because in the exam they will give you is 10 newtons per kilogram for the gravitational field strength. Okay, so lots of information there on work done. Hopefully you found that video useful and you managed to get some of the questions right. If you found it useful, then please press the like button below and feel free to subscribe. Thanks for watching.